It's that time again, everybody, to review and study for our common assessment number 2. So this is question number 1. It says, number 1, add 12.549 plus 3.9. Enter the exact sum. Well, that's going to be pretty easy. It tells us what summing is by saying it right here, add, right? So we're just going to add those things together. And when we're adding decimals, we also have to line up our decimals. So we have 12.549 and 3.9, right? So what I'm going to do is just line up my decimals. So I'm going to put my decimals right under this one. And there we go. Now what do we do with these empty spaces right here? Well, we're just going to add some zeros, right? Let's fill in those spots. We have 0 and 0. The rest is just a simple math problem that we learned in elementary, so this should be cake. So I added my zeros. I have 9 plus 0 equals 9. 4 plus 0 equals, oops, not 9, 4. 5 plus 9 equals 14. I'm going to regroup and bring my 1 up here, right? Oh, let me make them look a little nicer. So he's going to be right here with these guys. So now I have 1 plus 2 plus 3. That equals 6. And then 1 plus nothing equals 1. So is that my final answer? Well, not quite, right? Because I still need to bring my decimal down. So my decimal's right here. I'm just going to bring them right down. And it's going to go right in between the 16 and the 449. And that is our answer for number 1. Nice little review. Easy peasy, right? All right, number 2 says the grid shows the location of 3 points. There's A, right? A, B, and C. So it says enter the distance in units between point B and C. So we're looking for point B and C, right? So at this point we don't even care about what C is. This is pointless to us, right? We don't need this one. We're just trying to figure out A to B. So we got 2 different things we can do here. We can either go like this and copy each box. We have 1, 2, 3, 4, 5, 6, 7, 8, right? 8 spaces in between. That's one way to do it, and that would be the right answer. We'll say 8 units, right? That's the distance. We can also think about it like this. This is -5, right? So -5 to 0 is how many spaces? If we're doing absolute value, it's 5. And we have 0 to 3, right, over here. So now we have 3, or 5, plus 3, and that equals 8. So that's another way to look at it, which I think is easier because sometimes it gets confusing when you're counting these spaces. Just think about it. It's at -5 over here. So 5 to 0 is 5. And then this is at 3. So 3, it takes 3 spaces to get back to 3. So you add it together. 5 plus 3 equals 8. All right. That was number 2. On to number 3. Number 3, consider the points plotted on the line shown below. So we have these 4 points. We have A, B, C, and D, right? And they're all at different points here. So let's consider the statement in the table shown. Select true or false for each statement about the number line. So here's our first question. The value of point A, which is this one, is greater than -3. So we have this one at -4 and this one at -3. Which one is greater? Which one would the alligator rather eat, right? Who would he eat? Well, we know that all numbers to the left are always smaller, right? Oh, that's not left. So left is always smaller. Right is always bigger. Is -3 to the left or right at number 4? It's to the right, which makes it bigger. So the value of A is greater than -3. That is going to be false. All right, question number 2. The value of point B is greater than point A. Is B to the right of A? Absolutely. So it is greater than point A, right? That's all we got to think about. Which one's to the right? So this is true. And finally, the value of point C is less than -2. C is at 2. Is that less than -2? Would you rather have $2 or -$2? Or rather owe someone $2? No, right? The value of point C is greater than. So we're going to say false again. That concludes number 3. Nice and easy, right? It looks all complicated. It's not that complicated. It's pretty easy. Number 4. This is one of my favorites because it's basically done for you. All you have to know is the rules for multiplying with decimals. So it says use the fact that 432 times 78 equals 33,696. All right, so we know 432 times 78 equals 33,696. So it's given us this new number, look, it's the same numbers, right? Times 7.8 equals, we know it's going to equal 33,696. We just need to figure out where the decimals go. So there's a decimal here, and we're just going to count how many numbers are to the right of these decimals. That's all we have to do for multiplying decimals. So let's see here, there's 2 numbers, right? And here's 1 number. So 2 plus 1 equals 3. So I'm going to go back over here where my decimal is, because if there isn't a decimal, it means it's at the very end of a number. So it's over here. I'm just going to move over 3 numbers. 1, 2, 3. So my decimal is going to go, oops, right here after 3 numbers to the left. So 33.696. Super easy because it does the math for us already. So don't sit there and try to figure out what 432 times 78 is, because it already tells you it's 33,696. All right. Number 5, select all ordered pairs that are located in the second quadrant of the coordinate grid. Second quadrant, what does that even mean? Oh, I remember. That's when we have this little quadrant here. Let me turn that back to black. Right? And there's 4 different sections. We have quadrant 1, quadrant 2, and I'm sorry, these don't look like Roman numerals, but it's the best I can do. Quadrant 3 and quadrant 4, right? Think of that big C. It's gonna be easier if I draw it. The big C, right? 1, 2, 3, 4. Big C. Now we're looking for the ones that are in quadrant 2, right? The second quadrant. So -3, 5. If I actually had a number line and I had drawn it, it would be, right? It would be, say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know this is ugly, but doing the best I can here. All right, so if I went over -3, I'd be -3 would be right here, and up 5, right? So my point would be around here somewhere. Is that in quadrant 2? Absolutely it is, right? So we're going to say yes, this is 1. The next plot it gives us is 4, -1. So I'm going to go over 4. 1, 2, 3, 4. -1 would be down here somewhere, right? Is that in quadrant 2? No, that's in quadrant 4. So that's not going to be our point. So I'm just going to put a red line across this thing. That's a no, we don't like that one. How about -2, 0? I know this is a tricky one. Some people were getting confused. If I go -2, and 0, that means I'm staying right here on the line. And that is not quadrant 2, that's the x-axis. So that is not one of our answers. Let me make this a little bit smaller. So no, it's on the x-axis, that's not quadrant 2. So again, I'm going to say no. This isn't an answer. And our last one, it says -8. So -8's like over here somewhere, and then up 6. It's going to be like around here somewhere. Is this in quadrant 2? Yes, because this whole area, everything over here, anything, even though I didn't graph it all, is quadrant 2. Anything that goes negative and up. So yes, our last one is part of quadrant 2. It's going to be the first and last one. All right, number 6. It says consider the statements shown in the table. Select true or false for each statement. So the distance between -5.23 and 0 on a number line is the absolute value of -5.23 on a number line, right? So if it makes it easier, you can draw a number line and just think about it. Let's see here. This would be 0, right? And it's talking about -5.23. So -5.23, let's pretend it's over here somewhere. And it's asking, is this the same as the absolute value of 5.23 or -5.23? But we know absolute value means that this is positive, right? And it's just talking about the distance. So is the distance to get to 0 5.23? Yes, it absolutely is. We're just talking about if you were to go, let's say 5.23 miles to get to the liquor store, and you went left to get there, you would have traveled 5.23 miles, right? It's still a positive number. You can't travel negative. It's kind of like the direction you're going. All right, on this one, on number line is 3.75, absolute value of 3.75 and negative 3.75 on the same point. We know that's false. And the reason for that is 3.75 is going to be over here somewhere, right? And negative 3.75 is over here somewhere, if we were to plot it. They're not on the same point. We know if anything inside of an absolute value is always a positive number. And the last one, the distance from negative 10.94 to 0 is the same as the distance from 10.94 to 0 on the number line. Is that correct? Is this, if I'm over here at 10, I still have to travel 10 to get to 0, right? If I'm over here at 10, I still need to travel 10 to get to 0. So the distance is the same as long as it's the same number, whether it's negative 10.94 or 10.94. So that is true. The distance to get to 0 is the same. All right. Question 6. I'm stopping there for the first video. I'll continue with the next 2 pages. We're almost done with the whole homework. Look at that. Easy peasy. I lied because I didn't realize question 7 is on this paper as well. So question 7, the equation shown has an unknown number. So we have to fill in this blank space right here. It's divided by 2/5 and equals 5/18. Enter the fraction that makes the equation true. Well, we always know that when you're dividing fraction, you're going to keep the first fraction, you're going to change the sign, and then you're going to flip the second one, right? Or if you're in Miss Gonzalez class, you're going to reciprocate. Reciprocate. I hope that's how you spell it. Think of KCF, not KFC, but KCF. So we're going to keep the first one. We don't know what it is. We're going to change the sign to multiplication, and then we're going to flip the second one, right? So it's going to be 5. Oh. That does not look pretty. Over 2. I'll fix that in a second. All right, that's better. And that's going to equal 5/18, right? Let me just take this guy over here. Makes it easier. So what times 5 equals 5? That's pretty easy, right? 1 times 5 equals 5. And then what times 2 equals 18? That's also pretty easy. We all know 9 times 2 equals 18. So our answer, since we're keeping this number, is going to be 1/9. That easy? Pretty easy, right? As long as you keep, change, flip when you're dividing fractions.